So, first of all, let's understand about nucleation. So, a phenomenon whereby a nucleus or a tiny seed starts to form by a crystallization process is called nucleation. So, suppose we take water in a beaker and we put some solid and dissolve it over here. Okay, suppose we want to make the crystal of sodium chloride and dissolve it over here. Now we will make a saturated solution, that is adding more and more solute, that is sodium chloride, until the sodium chloride will stop to get dissolved. So there will be sodium chloride over here, right? That will, this water will be filled by sodium chloride. A saturated solution will be made over here. Now if the temperature starts to decrease slowly, if the temperature starts to decrease slowly, then a nucleus or a tiny seed starts to form. Okay, somewhere in the crystal, somewhere in the solution, a nucleus or tiny seed will start to form. Not only one, but there will be those multiple of those tiny seeds. There will be a lot of those tiny seeds. These are called the nucleus or tiny seed. Now nucleation processes, so nucleation possesses a large energy barrier. So to form nucleus, a large energy barrier has to be covered, okay, or has to be overcome. That means it takes a lot of energy or effort to make the nucleus, or to create a nucleation process, okay, or to initiate a nucleation process. Now to overcome this energy barrier, a supersaturation is required. So to overcome this energy barrier, that is initiate the nucleation, that is to form the tiny seed, supersaturation is required. I have already told you what supersaturation is. That means more and more sodium chloride will be added unless it stops to get dissolved. That is the saturation condition. Now if the temperature is increased, then what will happen? It will be able to dissolve more and more solute again. That means more sodium chloride will be dissolved over here. That is supersaturation condition. Okay, now the supersaturation can be achieved either by changing the temperature, or changing the pressure, or changing the concentration, increasing more concentration or decreasing the pressure. So these are different conditions by which supersaturation can be achieved. Now nucleation can either be homogeneous or heterogeneous. So in homogeneous nucleation, there is a lack of influence of foreign particles. There won't be any foreign or any extra particle. Hence can be carried out from highly supersaturated solution. So highly supersaturated solution which do not have any foreign particles are can initiate homogeneous nucleation. Okay. Similarly, in heterogeneous nucleation, there is the influence of foreign particle. There will be some foreign particle as well. That is some extra particle or some impurity over there. Hence, takes place more quickly, because that foreign particle will behave as scaffold. Okay. Now since the foreign particles can act as scaffold for the crystal to grow on, which reduces the surface energy requirement. Okay, suppose there is water over here. Now there is sodium chloride put over there. Now if we put some impurity or foreign element, now this will behave as scaffold. That means the nucleation process will not have to uh, generate a lot of energy, or we do not have to provide a lot of energy to begin the nucleation process. Few nucleus will come and join to this impurity, and this will behave as the scaffold. Okay, it occurs spontaneously at metastable condition, that is small supersaturation. Now metastable condition prevents formation of many nuclei. It won't allow many nuclei to form. Similarly, the second one is the growth. Okay, so the growth is the subsequent growth of the nuclei that succeed in achieving the critical cluster size. So more and more nucleus will come together and form a single crystal. Okay, form a single seed. Now that will if that attains a critical cluster size, if it has certain cluster size, that is the critical form of it, it will now start to grow. That means its size will start to grow. It will get bigger and bigger. That means the crystal is getting larger and larger. Supersaturation is the driving force of crystallization. We have already talked about this. Now, hence, the rate of nucleation and growth is driven by the existing supersaturation in the solution. So, supersaturation is the driving force of growth as well. So, as the growth proceeds, as the size is increasing, the supersaturation decreases. Supersaturation will start to decrease. To maintain a reasonable growth rate, to maintain a reasonable growth rate, the supersaturation has to be maintained, okay, which is achieved by, so supersaturation has to be maintained at all cost to to maintain a reasonable growth rate of the crystal. Now, the methods that can be achieved, the methods that can be used to maintain a reasonable growth or supersaturation are lowering temperature, isothermal evaporation, and flux growth method.